In lecture 2, we are going to learn what variables are and how they are declared. A variable is a symbol that represents a storage location in the computer's memory. The information that is stored in that location is called the value of the variable. One common way for the variable to obtain a value is by an assignment. Assignment has a syntax. Since I'm going to write the comments, so I'm going to put the double slash, going to write the assignment syntax is variable equals to expression. That means that the expression is evaluated, and then the resulting value of this expression is assigned to the variable. The equal sign here, the single equals to sign, is the assignment operator in C++. It assigns whatever value is over here to whatever variable is over here. So it goes from right to left. Okay, so we're going to put some examples. So first thing, I'm going to write the preprocessor directive, and we're going to include IO stream. Okay, just the code blocks actually puts out the suggestions. Just press tab to select that expression. Just press up and down key, and then going to write using namespace standard. Since that's a statement, going to terminate that with a semicolon, and then our main function integer main void. It's good practice to write void. Void means nothing. If I just don't write anything, it means there is nothing, so it's just essentially void. So a single curly bracket, it just close that curly bracket as well, and I'm going to write what this program is going to do. I'm going to write a comment over here. I'm going to say, the writing comment is actually a good thing, because whenever you revisit your programs, it might be difficult to read those programs. So whenever you have written those comments that this line is doing this thing, it will make your job easier to understand what you were thinking when you wrote the program in the first place. So this program is going to print something like print m equals to 44 and n equals to 77, something like that. So let's see how it works. So first thing I need to do is, these are essentially all comments over here, whatever is being grayed out. So I'm going to close this thing in a moment, or I'm going to minimize this a little bit. Okay, so I'm going to declare the variables. I'm going to write int m comma n. That means I've declared two variables. I'm going to explain this code in a moment. So for them space over here, another space. So the compiler doesn't really read any of these spaces. Essentially for compiler, this is actually a one-line program, but for our readability, we're going to use different lines for different things. So m equals to 44 semicolon. So what this thing did was it assigned, once again comment, assign the value 44 to the variable m. This is the comment. The actual statement which would be read by the compiler is this thing. This thing would be ignored by this compiler because this is just a comment. This is for our own readability. So if I write cout, the string modifier for output, and output operator, and I write the string literal in double quotes, I write m equals to, this is essentially a string. I can just write whatever over this thing. I can just write anything over here, so it doesn't make any difference none whatsoever. So m equals to, this is just a string which is going to be displayed just like it is on the screen. Another output operator, and I write actual variable name m. Then I write n equals to m plus 33. That means that what we do is that the value of m is 44, and 44 plus 33. 44 plus 33 is 77. So the expression is evaluated over here first, and then the resultant value of this expression, which is 77, is assigned using the assignment operator, a single equals to sign, to the variable. The name of that variable is n. So I'm going to write the comment over here, assigns the value, sorry, did I write the wrong spelling? Okay, assigns the value, it doesn't really matter, whatever you write in the comments, to the variable n. Okay, so I'm going to write cout and output operator and double quotes and n equals to, you can just write anything over here, doesn't matter, whatever, it's just a string literal, whatever you write over there. And then I put another output operator and the variable name over here, and then I write the and l to flush the buffer and have a new line. So if I run this program, I think the window has been open for a moment, so I need to close. I mean, this is from lecture 1. So if I select build and run, it will display m equals to 44, m equals to, here m equals to, and the value of m is 44, and since we did not write the new line character over there, the cursor is stuck still after m, not in the new line, so it is straight in the same line, and it wrote and n equals to, whatever you write over here is displayed over here. You can just write anything over here, and the value of n is displayed over here. So what we actually did over here was that we can view these variables like m and n like some kind of, they are, I mean, kind of a box, and it contains the value 44. So if I write these things, I mean, we can just draw over here. So if I draw this thing, I mean, let's say that I have a box, and that box name is m, right, and it contains a value 44, and I have another box named n, and it contains a value 77. These are essentially, I mean, the values contained over here, I mean, these are the values of these variables, and these variables represent some kind of memory location in the memory space assigned to this program. So if I go back to our program, so I mean, you can just assume like something like a box or something, and its name m is like the address on that box, or if you know what mailboxes are, I mean, not being used here in our country that much, but you can just imagine these things as some kind of a mailbox which has the addresses associated with it. So I mean, I'm going to say these are boxes or these memory locations in the memory space of the computer, and they contain the value 44 and 77, and these m's and these m and n actually are the symbols which represent these memory locations which contain these values. So the contents of these blocks are 44 and 77, and the important thing is the type of these variables is integer, int for short. So I mean, it's kind of a classification. I mean, what these memory locations can actually represent. If I've written int, that means that these variables can only contain integer values. They could be positive, they could be negative, they could be 0, but only whole numbers, integer, not fractional part. These in this example, we have declared the two variables m and n of type int in the same line. You can use multiple commas and multiple names of the variables, and they all would have the same type. I could have written enter m and for example p, or for example j, or any number, or any name over here. The important thing is I could have declared them in multiple lines as well. I mean, I could have written like this integer u, something like that. So it's up to you, whatever you want to go with it. You can, if you want to declare multiple variables of the same type, you can just use comma and write their names. Important part is that every variable in C++ must be declared before it is used. So that means that the format for declaration is specifier type, then name, and then it's an optional part, you can do it in another line, initializer. That's the for syntax to declare a variable and initialize it in the same line. I could have written integer a equals to 10. That means I have declared a variable which has a name a, it has a type int, it can only store integer numbers, and I've assigned or initialized this variable a to a value to have a value 10. Another thing is that this type here is integer. There is another something known as specifier. It's a optional word or optional keyword. I'm going to discuss that. We might have something known as specifier, something known as constant. If you want to use the same value again and again, you can just assign it as a constant variable, which will have some value in it, but it won't change in the program. So we're going to discuss that. This specifier is optional, but type, name, and initializer, that's we have just discussed just right now. The purpose of this declaration, the purpose of this declaration is to introduce a name to the program. This is to explain to the compiler what this name means. So the type tells the compiler, the type this int, that what range of values the variable may have and what operations can be performed on the variable. So what we have done over here, that we have specified that, we have declared a variable of type integer. It tells a compiler that this variable a or m, n, p, j, or u for that matter, these variables can only contain whole numbers and not fractional numbers. So if you assign a fractional number, it will just take the integer part. It will not round it off, it will not floor or seal that number, it will take the integer part only. For example, if I write m equals to 44.9, it will not round it off, it will just take the integer part, because m is defined as an integer, so it will only take the integer part. It will not make it 45, it will just take it as 44. So if you run this program, so we expect to see the same output which we did before. M equals to 44 and n equals to 77, just as before. So it just took the integer part, because we have defined the type of this variable m as an integer. So coming back to this program, the purpose of the declaration, which we have said before, that is to introduce a name to the program, and the type tells the compiler what range of values the variable may have and what operations can be performed on the variable. Location of the declaration within the program determines the scope of the variable. This is important. The part of the program where, what we mean by the scope is that the part of the program where the variable may be used. In general, the scope of a program, the scope of a variable extends from its point of declaration, and we have declared it, we haven't initialized it, but we need to initialize it. From the point of its declaration, the scope of this variable, where this variable is actually visible. This variable is declared over here, it's not visible here. So if I write for example u equals to 8, okay, so if I write u equals to 8 over here, the compiler won't know, it will not know what u is, because the u hasn't been declared yet. U is declared over here. So if I write, I mean, it will throw up an exception, it will throw up an error, it will refuse to compile because this thing is an unknown variable here. So if I write, let me comment that so the compiler won't read it. If I write u equals to 8 over here, now the compiler knows what u is, because u is an integer, and it will assign the value 8 to the variable named u. So the location of the declaration within the program determines the scope of the variable, or in simpler term, where the variable is actually visible. And by scope we mean the part of the program where the variable may be used or is visible. In general, the scope of a variable extends from its point of declaration to the end of the immediate block in which it is declared, or which it controls. I'm going to display that in some future example. A computer program essentially is a sequence of elements like this. I mean, many elements, and they are essentially called tokens. It's an old word. These tokens include keywords such as int, identifiers such as main, punctuation symbols such as these curly brackets, and these operators, the insertion operators, and so on and so forth. When you compile your program, the compiler scans the text in the source code, parsing it to tokens. If it finds something unexpected, or if it doesn't find something that was expected, such as if you have opened the bracket and forgot to close it, did not write the semicolon, or did not write the right kind of the operator, then it aborts the compilation and issues some error messages. For example, if you forget to append the semicolon that is required at the end of each statement, it will report the error saying that there is some semicolon missing, or some syntax error such as missing quotation mark or a missing closing brace may not be described that clearly. So instead, the compiler will indicate that it found something wrong near the location in your program. So that, I mean, let's try that, how the error comes up. So if I just write build and run, sorry, click build and run, it says one error over here. Let me go over there. U was not declared in this scope. It doesn't know u. Okay, so let's do that. Let's say if I declared the variable and initialize it but forgot to include the semicolon after end of statement. Let's see, it says that error expected semicolon before int. So before int is I mean, right over here. So if I put over there and if I recompile this thing, it says no errors. Okay, no warnings. Okay, so let's simplify our program just to understand the concept of these tokens. So if I write I'm going to delete these comments. Okay, so we're going to make it very simple. Print and select these lines as well. Alright, so the first line is actually a comment over here, so it's not going to be read by the compiler. If I declare the variable integer n equal and initialize it as well, it will display n equals to n equals to whatever the value of n is. You can just write any string over here, and the output is that window is open. Need to close that, so that is enabled again, and it says n equals to 44. Okay, so I mean, the source code here, source code contains many tokens. It contains int. I mean, what tokens are? Sequence of elements. I mean, these are elements, and the whole program is essentially a sequence of these elements. So there are many tokens. It has int, it has main, it has these round brackets, curly bracket, int keyword, n equals to sign, 44, semicolon, cout, insertion operator, double quotes, string literal, and then double quotes closing again, and then this insertion operator, and this n, name of the variable, another insertion operator, and nl, and semicolon, and this closing curly bracket. So I mean the compiler just ignored this thing, and it contained many tokens. So whenever it sees an error, it will throw up an exception. For example, if I write this, just I have demonstrated a few minutes earlier, it says that the error expected, it says that a semicolon was expected. Okay, here it's pointing where the error was, or where the error is nearby, so we need to look at the lines where this, or nearby lines where the error could have been. So the compiler says that this, I mean the token expected was semicolon, and it did not find that semicolon after the statement. Here we have let's remove that error by putting the required token over there, and let's rebuild this thing, and it says n equals to 44 with no problem. Okay, so now we want to, or what we have done is we have declared the variable n and initialized it to the value 44. So it is really important that you must initialize a variable before using them, and it's better to initialize the variables whenever they are declared, so that they won't contain some value. For example, if I write integer n equals to 44 and declare another variable integer q, but I did not initialize this variable, let's see what this q is. Put a something known as a, I mean like some space bar, okay, some blank spaces, a string literal over here, and put q over there in the outer stream, and l. Let's see what q actually represents. It's going to display n equals to 44 just as before, but it's going to display some value of q, because let's see what q is. It did not put some error, it did not display any error, it displayed 16, but we did not initialize q with 16. It is definitely some garbage value. Whenever you have declared a variable but we did not initialize that variable to the value which we wanted to have, it might put some random value, because whenever you declare a variable, in this case we have declared a variable q with a type integer, the compiler, after translating it into machine code, reserved a memory space of 4 bytes, because it's an integer. It might be 2 bytes, depends on compiler. It reserved a memory space in the memory in the computer, and it named this memory space as q. The symbol q represents that memory space. It has an address, it has some value, but that memory might have been occupied by some other program. It might have written some other values over there. So it has allocated a memory for us to use, but we haven't initialized it with our values. That means it might be containing some garbage values. Some compilers might throw up an exception or say that this variable is not initialized as of yet. These are essentially good compilers, but in this compiler which I am using, it just displayed the garbage value. It could have been anything. I mean, let's write another variable, integer q, and r, s, and t. We have 4 variables. Let's see what it's declared over here. So I'm going to put some single quotes over there, or a single space, and put r, a single space because it's a character, and put s, an output, single space, and put t. I mean, what I'm going to demonstrate is that they might contain some garbage values. I mean, it could contain any values really. I mean, it's not put any look, the numbers is displayed. N equals to 44, that was the initialized value. That is our correct bona fide value. This 16, we did not initialize it, and r has the value 0, s has the value this weird number, and t has the value 0. That means if you are using the variables without initializing them, your programs will and probably will behave weirdly. I mean, or they might put some errors over there. It's really important to declare the variables and initialize those variables whenever they are declared. Okay, so I mean, some uninitialized variables and you forgot to initialize them, they might cause huge amount of errors, and it's really hard to figure out where these errors coming from. So it's a good practice that whenever you have declared the variables, either use them immediately to some proper initialized value, or initialize them. I mean, that means assigning the variables some values, so that your program would not put some weird looking errors which are hard to point at. Okay, so coming to this integer n equals to 40. What is n? N is a variable, and C++ it's actually an object of type integer. So an object is a contiguous region of memory that has four things. It has an address, it has a size, it has a type, and it has a value. So this n has an address. What that address is, you can use some ampersand operator to see that address, if you want to see that. So let's see. If I write ampersand over here and I write address of n, I'm going to discuss this operator in a very future lecture. We're just going to see. I'm going to delete these things. I mean, these are just essentially distractions at the moment because we haven't initialized those variables. Delete, right, and going to delete this line as well, or we just comment it, no problem with that. So let's see what the address is. Okay, it's displaying some hexadecimal number, 22FE4C. This is some memory address in the computer memory. Represents some, I mean, the n is, I mean, the value 44 is located at this address. 0x means it's a hexadecimal number, and in computer memory they are essentially all ones and zeros. Hexadecimal numbers are useful to represent binary numbers because four binary numbers represent one hexadecimal number. So, well, just take my word, it's actually a hexadecimal number represents a memory space or memory location in the computer memory. And each object, I mean, the integer n is an object. It has a address, we have seen that. It has a size, going to see that what size is, as probably maybe 4 bytes or 2 bytes. It has a type, that means int, and type defines what values it could have and what operations it could have, and a value. In this case, it has a value of 44. So coming back to our original program, I'm going to discuss, going to delete that address operator, the ampersand operator. I'm going to delete that. I'm going to display n equals to 44. So the address of an object is the memory address of its first byte. That means what we have seen, that hexadecimal number was the address of memory address of this first byte. I mean, n probably is occupying 2 or 4 bytes. I don't know. I mean, it depends on compiler. Going to see that in a moment. Going to use some size of operators here. The size of an object is simply the number of bytes it occupies in the memory. Value of an object is the constant determined by the actual bits stored in its memory location and by the object's type, which prescribes how those bits are to be interpreted. Okay, so here the value is 44. For example, if I write, I mean, if I've written like n equals to 44, it has the address just seen. It has a size 4 bytes, type integer, and value of 44. The type of an object here is determined by you, whoever is writing the program, the programmer himself or herself. The value of an object may also be determined by the programmer at compile time or be determined by at runtime. The size of an object determined by the compiler. For example, probably in this compiler which I'm using, integer has size 4 bytes. Whereas if you have used some other compilers, previous compilers or old compilers, integer had the size of 2 bytes. and the address of the object is determined by the computer's operating system at runtime. So what actually happens is that since we have built and run this thing, it has developed an executable file named as example1.exe that was actually running at the command prompt. So whenever we are running an application, it has developed an application with a file type of exe or executable type, because I'm in Windows environment. Whenever we click or run that application is assigned a memory space by the computer. So it's not necessary that you get the same address of this variable n using the ampersand operator whenever you run this program. It might be possible you get the same address, it is possible you get a different address, because whenever we are using different programs, the same random access memory is being occupied by different programs, and those different programs would be writing different, they would be occupying different memory spaces. Depends on when you run this program, your example1.exe, because we have built it into an executable application. It depends on what memory space has been assigned by the operating system to your executable file. Some objects might not have name. A variable is an object that has a name. An object defined here has a name, is actually a variable with a name n. It is possible that some objects might not have a name. Thus, how to identify those objects? We are going to use some addresses which are going to refer to the first byte of the memory space occupied by that object. This word variable here is used to suggest that objects value can be changed. An object whose value cannot be changed is known as a constant. Constants are declared by preceding its type specifier with the keyword const. For example, I can write constant type integer. I'm going to write n. Once again, keep in mind that C++ is case sensitive. So this n, small n, and this capital N are two different variables or two different objects. Okay, so if you're not happy with it, you can just use another name, but I could have used n with it. Let's say m equals to 55 or maybe 20, just a number. Okay, so these constants must be initialized whenever they are declared. You can just write constant integer m and then declare it sometime later. No, it's not possible. It might throw up an exception in some compilers. So they must be initialized whenever. Initialize means assigning a value to those variables, so they must be initialized whenever they are declared. So this constant specifier is used to, you can have let's write a simple program of which essentially does nothing really. You can have a program of, I could just write, this is a program which does essentially nothing. It has a return 0 and that's it. Or you can have a program which might have no output at all. Let's say we can write constant character is a type, going to discuss that in a moment, beep equals to such as the integer is a type, so is the character is also a type which can store single characters. So I can have backslash b over here, and I have a constant integer. That's right, max integer. This is a name really. It's a customary way to, if whenever we are writing constant variable names, it's customary to write them in all capitals so that they are distinguished or easily identifiable by the other variables. Equals to some weird number. Okay, make sure you do not exceed the range. I'm going to discuss that what range is. And let's write constant integer n equals to max integer divide by 2. It's a mathematical expression. And constant float, once again float is a type, kilometer per mile, just a name. Whenever you are using the names of variables or constants, make sure you do not start with a number. Do not use some special characters. You can only use underscores and letters, and you can also use numbers, but do not start with a number. You can end with a number or put numbers in there, but no in the name of those variables if you want to. So let's write kilometer per mile is 1.6, probably 1.6, something like that. Okay, float is used to represent fractional numbers which contain a decimal part, mantissa and things like that, and exponential part. And let's write another constant. Double means double precision floating point number. Pi is 3.141 592 and things like that. Okay, so whenever it is expected that these values do not change because they are defined with a specified constant. So whenever we want to refer to these numbers and they are not being changed in the program, so we just write maxint or n or km per mile or pi. We're going to use these names of these constants to represent these numbers. Now we are going to discuss the input operator. The input operator is represented as I'm going to change the heading over here. Input operator is represented as like this arrow. This angular brackets. The output operator was going from right to left. The input operator goes from left to right. So let's write a program, a simple program. I'm going to delete these because I'm not going to refer to in the future, or maybe I just rewrite it again. So if I declare the variables integer m and of type integer objects, I'm going to write cout string, and the output operator I am going to display enter to integers. This message is going to be displayed on the screen. I put a space bar over here so that the cursor is is one space after it, and I write cin, and I put the input operator m, another input operator n. So whatever the user is typing on the computer, since we have said that enter two integers, we expect the user to type two integers. If he or she types something else, something else would happen. It will probably be converted into integers, or some weird result might happen. I'm going to discuss those exceptions in some future lecture. But let's say the user has typed 22 and then he's typed 55, so that the first 22 is assigned to integer m, and the second number which the user has entered on the keyboard is assigned to the variable n. I'm going to discuss that in a moment. Okay, so let's output those values. Cout, output stream modifier, output operator, and I'm going to write m. You can just put essentially any string over here, and it will another output operator, and the value which the user has entered is going to be displayed over here. Then another string, comma, spacebar, any value, any string you want really, and then another output operator n, and then end of line. Then we declare double precision floating point variables x, y, and z, and then we display a message on the screen saying that enter 3 decimal numbers, and we expect the user to type in good faith and do not write any letters or something like that. Okay, so we just have an input stream modifier cn, which takes the input and assigns the input numbers or the decimal numbers to the correct variable. So in input operator x, and then the second input goes to y, and the third input which the user would enter goes to z. then we see out whatever the user has entered, and we write the string x equals to and another output operator. The actual value of x is going to be inserted over here, and then we write another string comma y equals to, and then another output operator y, and then another string comma z or z equals to another output operator and l. Then we declare another type of objects character, just c1. I've said that you can use the name of the variables, I mean you can just name them anything, but don't start the name of those variables with a number. c1, c2, c3, c4, four variables. Okay, so we just put the message over here, enter 4 characters, spacebar, and then semicolon. Okay, so what it's going to do is it's going to prompt the user for 4 characters, and then we're going to take the input cn input operator c1, and the input operator, the second character goes to c2, and the third character goes to c3, and the fourth character goes to c4, and whatever the user has entered, we're going to display that. I'm going to write c1 equals to, and then and you can just put any string over here, and c1, the actual value of c1, which is actually a character which the user might have entered, would be displayed over here at this place. Another output operator c2 equals to double quotes end of a string c2, the value of c2 would be displayed over here, and c3 equals to end of string, and the value of c3 would be displayed over here, and another string c4, put some comma over here, so c4 equals to end of string and c4 and end line, and that's it. I mean the curly bracket has been closed. Let's see if we have some errors. Okay, enter 2 integers. So just put like 55, enter 77, sorry 77, and then 55. It says m equals to 77 and n equals to 55. Sorry, the first prompt was due to my antivirus software is bugging me. So it's whenever we enter 2 integers, so m, the first number 77 was assigned to m. Whatever the console input goes to m, and the second input goes to n, and we see out this thing m equals to 77 and n equals to 55, and then endl, that means the new line character has been inserted, so we have in the new line, and output is output of it is also flushed. Okay, enter 3 decimal numbers. So if I write 34.1 and then press enter, and I write 67.9 and then press enter, and I write 44.4, enter, that means the first input went to, using the cn stream modifier, the console input went to x, console input went from console to x, the second input went to y, which was 67.9, and the third input was entered to z. Oh, I think we forgot to display z over here, so it's not displaying the value of z. I should put z and then another output operators and then put endl over here. Sorry about that. Okay, it says enter 4 characters. Let's see if I can do that. Okay, enter 4 characters. If I write a, enter, ampersand, enter, star, enter, and b, or maybe small b. Let's say c1 equals to a. The first character, I mean, you could just write uppercase, lowercase, whatever, any numbers or anything. You can just write numbers in there because numbers are also characters. A goes to c1, and this ampersand went to c2, and this console input of this star went to c3, and the letter b was assigned to c4. And it says press any key to continue, so I need to correct this thing. It says I should write z over here, and then now it says now it's okay. Okay, so that concludes our lecture 2. Here we have used the input operator, and that input operator is used to take the whatever is, I mean, the console input. The cn stream modifier takes the input stream, and whatever the numbers or whatever the types or whatever the inputs are being entered by the user, separated by the enter key, are assigned to the relevant variables. So the first input went to m and the second input went to n. Let's run this thing again. Okay, enter two integers. So enter two integers is this line, enter two integers, c out. We have declared two integers, and then we have written cn m n. So if I write like 99 and minus 765, so these two are integers, and they are assigned using this input operator. Whatever is entered at the console input using the cn stream modifier, we have taken the console input and assigned, going from left to right actually, assigned to the first input has been assigned to m, which is 99, and the second input, the minus 65, has been assigned to n. And since we have used nl, so this thing m equals to 99, m equals to, you can just write any statement over here, equals to this 99 is the value of m, and this thing, comma is here, n equals to minus 765. Minus 765 is the value here, and nl means new line and output buffer flush, so it's at new line. And now it's just, I mean, if we haven't done that, that's this enter three decimal numbers would be displayed right next to this 765 in the same line. Three decimal numbers, any numbers you want, like 99.0000765, enter. That means the first number has now been assigned to x. Then we put 87.98765, whatever, because the decimal precision. And the second, since we have pressed enter, the second number has now been assigned to y, and now we put like minus 0.00000, any number you want to, because it's a double precision floating point. And now it says that x equals to 99, y equals to 87.988. It doesn't mean it has rounded off the numbers. This is important. It's displaying those numbers. How to display the full precision, we are going to discuss that in a future lecture, or you might want to look it up, that how to set the display format, or I mean, you need to use something known as set precision directive or set precision statement before using the C out, so that you can display the full amount of precision you want. This is the standard display option, going to display the 4 spaces after the decimal point. Doesn't mean it has rounded off the number. It might have, I mean, if you have put the so much precision that the double floating point, which is actually an 8-byte number, it has a huge amount of precision storage capacity. But if you have put such a large number or such a large precision value after the decimal point, it might round off at the very end, which is known as a quantization error, which happens whenever we have very fine values stored in the computer. Now it says see out x equals to whatever value of x is here is. Once again, x, it's not necessary that x has now been rounded off, we don't know yet. We need to use something known as set precision. Okay, y equals to this number. Once again, not necessary that it is round it off, it's just using the set precision to 4 decimal places. You might want to look it up at the internet of what set precision actually means in the C++ context, and z equals to whatever value we have entered over here. It's displaying the base part and the exponential part separately, and that's how the floating point numbers are stored. Once again, if I've written float instead of double, I would have assigned 4 bytes to this variables. If I've written double, that means I have now double precision floating point decimal part numbers, which has the capacity of 8 byte storage. Characters, and now we have seen enter 4 characters. We have declared the 4 variables of type character, and see out is enter 4 characters. Just write any characters, like for example J, enter 9, enter for example this thing, enter, and something like this thing. So it says that C1 has the character J, C2 has the character 9, C3 has the character this whatever you want to call it, C4 has the character tilde, and the process returns 0 because return 0 is understood to be here. We haven't written it explicitly, but this return 0 means that this function is returning a integer value of type integer, integer value, and if it managed to run successfully, it will return 0, which represents the successful completion of the program.